module, but they may be illiterate in any language. And so you can't have an instruction manual as to how these things operate. And so the challenge was to build a system that was what I call intuitively obvious, that someone could just look at it and intuit how to plug it together and make it function. And to that end, you have to make sure that whenever you plug something in, it's not going to start smoking. So you have to make the connectors so that they only go a certain way. They can't be short-circuit accidentally, and so on. So that was a challenge. And beyond that, you have to understand what the end user actually needs. I think often engineers tend to want to design the most efficient thing, but sometimes the most efficient design is not exactly what people really need in that particular application. So by interviewing the end users and the people who understand the problem domain, you get a better sense of what exactly the problem is they're trying to solve. A little bit more about me. I've been working in electronics since I was 13 years old. I started etching circuit boards back then and doing analog and digital design. And now I'll be 64 this year. So I've been doing it a long time. I've designed scores of technologies, have a bunch of patents, all kinds of stuff. I really love this stuff. I really enjoy electronics. I enjoy physics. And I just get excited about doing it. In my career, I've done applied research in nuclear medicine, a lot of medical technologies. About a third of my work is in medicine, a lot of robotic stuff. I did a lot of research at Carnegie Mellon Robotics Institute. I do a lot of industrial automation problems, special sensors. One of my recent patent applications is for a near-infrared spectrometer that allows us to analyze chemical compounds on site, just looking at the near-infrared spectrum. I'm working on a new device right now, which is a colorimeter. Measuring color is quite complicated because of the way we sense color. And so you might imagine that you can just put like 3 sensors, red, green, and blue, and get a real precise measure of color, but that's it's a little bit more difficult than that. The eye actually uses information from all the wavelengths across the spectrum in perceiving color. And so if you had a simple trinary color sensor, you're going to lose all the information relevant to all the other colors in the spectrum except for those 3. Thank you. In this particular design, I had to find a light source that would fully fill the entire spectrum so that I could get an accurate representation for all the color components in the target sample. But I've done patents in a big variety of things. I regularly lecture on robotics. It's one of my popular areas. And I talk at a lot of universities around the world on a whole variety of things. I've been an independent consultant now for 20 years. And I consult in everything that involves physics or electronics, which is pretty much everything. If you can imagine, I get customers in every different field. One of my clients right now, I'm developing a new scalpel for brain surgery. I happen to have some coursework also in neurophysiology. So I'm teaching them about neurophysiology in that company, as well as solving some physics problems for them with respect to the way the scalpel functions in tissue. And did some electronics design for them as well. I'll give you a little cautionary note, and that is learn all your lessons well. I can tell you that in all my years of college education, I've probably used every single class that I took. But I went out of my way to make sure that my career was really challenging. I've been doing research and development in a wide range of areas, and I compete with a lot of high-level people, so I have to be good at it. So I started out when I was in college to make sure I was the best one. And I think each of you should do the same. That should be your plan, to be the best one. In the universe of technology people today, it's very competitive, very competitive. And so you have to imagine yourself as an entrepreneur and a competitor from right now, and start doing things to make sure that you're going to be one of the stronger competitors when it comes to getting that job that's really interesting and pays you a lot of money. I actually do a long lecture. I do an hour-and-a-half lecture on how to optimize your career and optimize your income. But I'm not going to do that today.
No, go ahead.
Yeah, I can come back. Do you want to go ahead and get something to eat or drink first? Let's take a break.
So let me
Go ahead, Ed.
welcome everybody here. I know some of your faces, but not everybody, but I'm Glenn McKnight, and you've met Butch already. As Butch mentioned, we worked in a selective team that was selected with the UN, and was the UN Foundation and the IEEE Foundation. And they looked at, I think it was 32 millennial goals, development goals.
That's right.
And they boiled it down to 3. And we were lucky enough to work together on the reliable electricity project, which we were given the simple task of coming up with a 1 kilowatt open source solution to solve the energy problem for the 2 billion people in the world, which will never have energy. And so Butch was the chair. And we started with a lot of people, and by the end of it, wasn't so many people.
That's right.
For one reason, the money dried up. What happened was there was a little thing called an earthquake in Haiti, and so all the money got funneled to Haiti, and who knows what happened with that money. But the idea of the plan was to come up with a design and then create after the design is actually build it and then roll it out. But the difference is, he actually did it with his own money. He went and partnered with Villanova. He's a very modest guy. He actually worked with Dr. Pitball Singh, and they actually implemented and rolled out in 2 countries, in Nicaragua for one, and in Kenya for the other. So over the years, we've kept in touch. We have a lot of synergy, and he did a fascinating project in Kenya, and they had a problem with water hibiscus in Lake Victoria.
That's right, yes, that's right. Water hyacinth.
Water hyacinth.
In Victoria.
And basically, we put our heads together to come up what to do with the product. You know, it's a problem. How do you convert it? So it ended up being there's a serious issue of access for girls, menstruating girls having access to feminine pads. And so he actually worked with the local community, creating an actually cost-effective local solution, which is completely different from electrical engineering, but when you put your thinking cap on, the amazing stuff that can happen. Joan, did you want to say something about the foundation?
Sure. Hi, I'm Joan Kerr, and I founded an organization in 2003 called the Foundation for Building Sustainable Communities.